Right, so this is Module 30, and we've come off the C string discussion, and now we're turning our attention to the string class. And as I talked about a little bit in the last module, in practice, the string class is really the newer approach, and it's not all that new. It's maybe 20 years or so. But in terms of the C language, which is 35 years old, this string class is is the newer way to do things. And as we'll talk about a little later on, there's lots of good reasons to use the string class. But I also want to start out by saying that to be able to use a string class and be able to understand the string class in depth, we need to understand what the word class really means. C++ is an object-oriented program, and we're going to touch upon that today in this module. But really, you're taking CS1. The focus of Computer Science 2, so CMPS 148, is really on objects. So a lot of this lecture, or a lot of this module, is somewhat informational. We're not going to put to practice a lot of the object-oriented concepts we talk about, but the string class is easy enough for you to use without really understanding the internal details of how these things are created. So it's kind of a nice introduction to object-oriented programming without getting too far into the details. So the textbook, strings are introduced actually very early on. We skip them, but so we're going to go back to chapter 4 now, and I would encourage you to read that chapter carefully. I'd also encourage you to look at more details on objects in chapters 9 and 10. So again, that's out of the scope of this course, but it's a lot of really good background information, and especially if you're a computer science major, you're going to be taking Computer Science 2. Computer Science 2 is all about object orientation. So again, as we start to get towards the end of this course, we're getting into some topics that are going to be valuable down the road, or are going to be taught in more depth down the road. So as I said, C++ is an object-oriented language. So we need to really understand what an object is. An object type is fundamentally different than a primitive type. So primitives are things like integers, characters, floats, doubles, booleans, all of the standard data types. They're called primitive for two reasons. One is that they're sort of native to the C++ language. They're built in, they're fundamentally parts of the language. They're keywords. Their data types are keywords. Objects are not built in necessarily to the C++ language, and when we use object types, we'll notice that their data types are not keywords. That doesn't necessarily mean you can use them wherever you want, but they're not quite the same. Things like integers and doubles and floats are also called primitive in that they're very simple. An integer is simply a set of bytes, 4 bytes, that can hold an integer. A float is probably 8 bytes, but it can only hold one individual floating point value. And there's really nothing that we can do with them other than use operators to combine them to make expressions. Object types have the capability of holding multiple pieces of information within them. They're complex structures, or potentially complex structures. They don't necessarily have to be. They also have methods associated with them. And we're going to talk a lot, we're going to see a lot of examples in this module of methods associated with this string class. So when we work with primitives, we're used to using operators, right? So we've got 2 integers, we can add them together with a plus sign. Object types have these things called methods, and there's several object types that are built in to the language. They come kind of standard fare. In addition, beyond the built-in ones, you can also create your own object types. You can create your own classes. And again, that's the focus of CMPS 148. So in this module, we're going to be focusing on the string data type. And to use the string data type, we need to do a pound include string. Now, just simply looking at using the string class, remember what it's going to hold. It's going to hold a sequence of characters. It's going to represent a sequence of characters. But objects are generally built or created such that you don't really need to think too hard about the details. In fact, a big part of object-oriented program is the idea of abstraction. And abstraction is all about hiding detail behind an interface, behind a set of language features that make it easier to work with the data types or work with the functions. We've already actually talked a little bit about abstraction when we thought about top-down functional design. Abstraction is not completely hiding details entirely. It's the idea that we're gonna put detail at a location in the code or a part of the code that we don't constantly have to deal with. So to create a string, a C string, we need to create an array. We need to know that it's an array. We need to know that there's a null character at the end of it. We need to know where the indexes are. To create a regular string, we just say string A. We declare it just like any other variable. And that's your first little introduction into the abstract nature. There is actually an array being created behind the scenes. When we say string A, there's actually an array. There's a null character going into that array. There's a whole lot of detail that happens behind the scenes, but it is in effect hidden from us, which is a good thing because it allows our code to remain fairly simple and straightforward. String variables, not all classes, but strings can use the equal sign operator, and we can also use the double equal sign to compare, less than, greater than, compare them in terms of where they are in a dictionary. So I can create a string A, string B. I can assign them with the assignment operator. So right now, just looking at this, it almost looks like string, and really, I shouldn't say almost, it is this missing data type that allows us to use double quotes and create literal values of strings, concatenate strings with a plus sign, sort of how we might have wanted to use it early on. That's one of the reasons the book introduces it so early. I introduce it late in this set of modules only because we have to deal with methods. So up until this next slide, if we look at all these operations, we're using standard operators to work with strings in a way that sort of should make a lot of sense. What we see is we can also use methods. And here's where the syntax gets a little different. But in fact, and if you remember the last module, we saw this dot notation. To find the length of a string, we don't use string length. We don't use the standard C string functions. The length of a particular string can be gotten by calling length on the actual instance, on the variable itself. So if I want to find out the length of A, I call a.length. It's not length with A being put into parameters, notice. This dot notation means that this is a method that is attached to this object, that's attached to this variable. So it's going to return back length. It returns a return value just like any other return value. This dot notation, the variable will always appear on the left-hand side. The method, the function name is on the right-hand side, and we can put parameters into here. Length does not require any parameters, but we'll see plenty of examples where we do. The length function, of course, returns something different for A when it's called with A and when it's called with B. And I'm going to kind of go through in rapid fire now a bunch of different functions. And one of the things that I want to stress here is that there's actually a lot of functions attached to the string class, a lot of methods attached to the string class, and there's a lot of interchangeable ways of doing specific actions. I'm going fairly fast because once we understand the semantics, once you understand the syntax, the dot operator and calling a function, the functions are all called the same way. They might do something differently, but they're all going to be called the same way, and they're all going to work the same way. And in fact, as you continue in computer science, you're going to be confronted with writing programs constantly that use functions that you've never seen before. You're going to have to read the documentation. You're going to have to explore the documentation and find out what functions are available to you. So you don't want to think about programming as sort of memorizing all the functions and memorizing all the different options that are available to you. It's much more typically the average programmer is going to be accessing documentation via online or on a textbook constantly, and using functions that they've never seen before to get the job done. So don't think that we need to memorize all these functions necessarily right now, but you just need to understand, have a reasonable expectation as to what's out there. So in terms of initialization, we can initialize with the assignment operator. We can also initialize a string using this constructor syntax with the parentheses. It's almost like a function call. So notice that we've got the data type followed by a variable name, and we're initializing it right off the bat by using these parentheses. Either way is perfectly fine. The append method allows you to concatenate or to add something to the end of a string. So if we look down here, I've created two strings. I create another string and initialize the welcome to C++. If I do s1.append hello world, S1 is initialized. If you don't do anything with it, it's initialized to an empty string. The append function adds hello world to the end of it. S2 is being assigned to hello CMPS 147. If I print these all out, you can see what would come out here. If I call append and put great to be here at the end of S1, we see hello world, great to be here. Okay, so the append function will actually modify S1. Notice we can also print out a string object just like any other variable that we've seen before. S1.append great to be here is exactly the same as saying S1 plus equals great to be here. So the plus equals sign also works with strings and it concatenates. Just like we can use an equal sign, there's also a method to do that, S1.assign. Just a little bit of a background here. In CMPS 148, you'll learn all about making your own classes, and you'll learn that you have to optionally override these operators. You have to go through a little extra work to make your classes work with these operators, like the assignment operator. Typically, most classes have a method way of doing things. S1.assign goodbye will just simply make S1 equal goodbye. And then convenience operators will be provided as well. And that's why you see two ways of doing the same thing. It makes absolutely no difference which way you work, which way you use. A lot of people will prefer using the methods. But this is clear, potentially a lot more clear. The string class also allows or provides a lot of methods for manipulation. For comparison, for interrogation of the string. So if I create a string S1 with this open and close parenthesis constructor syntax, it's initializing S1 to be the string welcome to C++. I could have also done string 1 equals welcome to string plus plus, or to C++. The length function is very similar. Actually, there's a size function that works exactly the same. Right, so both of these functions essentially just return how many characters are in the string. There's 14 characters in welcome to CMPS, welcome to C++. The C-string method, C_str, it does exactly what it sounds like. It actually returns a C string representing the same exact string or the same exact sequence of characters that's held within the string class. So why would we have a function like this? Well, it turns out that a lot of older code, a lot of code that's written in C, which is a subset of C++, only works with C strings. And if your code has to interface with any of that older code, it might need to take one of its strings and turn it into a C string, and that's the way you could do it with this function. I can compare things. Remember we saw in the last module string compare. And that returned less than or a negative number if S1 came first in the dictionary and a positive number if S2 came first in the dictionary. S1.compare S2 works the same way. It'll return a negative number if S1 comes before, a positive if S2 comes before. It'll return 0 if they're equal, so if I want to check to see whether two strings are equal, I can do S1.compare S2. Or I could do S2.compare S1, and it would essentially be the same thing. And of course, that's going to print out that they're not the same. If we want to change particular characters or get rid of particular characters in a string, there's a couple of methods to do this. So first off, to get a particular character out of a string, we can do s1.at with an index, all right? And so the 5 as the index is just going to go 0, 1, 2, 3, 4, 5, and return a single character. Much like if I was dealing with a C string, I could do S1. If S1 was a character array, I could do a bracket and 5. And in fact, I can do S1 bracket 5, and that'll work as well with a string. So I'm showing you a method way with the at method, but I could also do that with brackets. If I want to remove portions of the string, I can call erase. S1.erase will go to the 7th index and erase 3 characters, T, O, and the space. And when I print that out, I'll see welcome C++. I'll get rid of those 3 characters. S1.empty will return yes or no, or basically a 0 or a 1 if it's empty, 1 if it's empty, 0 if it's false. S1.clear actually changes the string, and it clears it. It removes all the content. So when I call S1.clear, S1 then is an empty string. It has no characters in it. And of course, when I print out the return value of S1.empty, then I get 1 because S1's been cleared. So erase will help you get rid of portions of a string. S1.clear or .clear will get rid of the entire string entirely. And it can be reassigned and changed later. We can get substrings, so we can take a larger string and get returned back to us a new string representing a certain portion of it. So S1.substring07 goes to index 0, counts out 7 characters, and returns a new string. A new string object will be returned. It could be assigned. I could say string S2 equals S1.substring07. And that's going to give me a new string that just says the word welcome, and that'll just print out. If I go to index 5, count out 5, I see me too. What I want to point out of particular note here is that it's a little bit resilient to programming error. If I say give me the substring that starts at 11 and give me all 12 characters, it's not going to crash. It's actually going to honor the fact that that's the end of the string. And really, this is an array inside the string class, and it has a null character. So the code within this substring function that we're using is smart enough to figure out that, you know what, I can't give you 12 characters, I'm only going to give you 3. We can search for particular substrings. So s1.find will scan through the entire string looking for the substring me. Once it finds it, it'll return the index where it found it. So 0, 1, 2, 3, 4, 5, it found me at index 5. S1.find O will find the first O. If you want to continue on finding more, you'd have to call find again. And instead of starting at 0, which is the default, you can provide an extra parameter. And so they're really just 2 different functions where you say, please start at another index. So if we find O at index 5, and now we want to find the next O in this string, we can call s1.find O starting at index 5, starting here, and then we'll scan across and find this one. Insert, replace, do much what you would expect, right? So s1.insert ANSI is the standards body that governs C++. We can go to the 11th index right here and inject ANSI space, and now we'll get welcome ANSI C. I can go to the 11th index and replace 8 characters. So go to the 11th index, replace 1, 2, 3, 4, 5, 6, 7, 8 characters with the word Java. And now I've got welcome to Java. And so the replace function starts at a particular index, essentially erases 8 characters and inserts Java. Right? Replace really is a combination of an erase call and an insert. And it'll take a lot of practice to use these correctly, but we'll have some time for that. I mentioned earlier accessing particular locations, accessing characters within A string, I can do the at function. A.at2 will return back an L. But also A2 will also do the same thing. A is not an array, but it's made to look like it. The notation with these brackets will also work with the string object. Reading strings from users. This is something that really catches people off guard, and it's an easy one to forget. So really concentrate hard with this. When we read from the user for a C string, those character arrays from the last module, we use cin.getLine. If we're trying to read a string object, from the user's perspective, there's no difference, right? They just type a string and they hit enter. But if we're reading it into an actual string data type, we cannot use cin.getLine. Use the function getLine. The first parameter is cin. The first parameter is where you're getting it from, and the second parameter is the string. Notice there is no maximum size because technically there is no maximum size for a string. It grows dynamically for us as we need it. So one of the nice things about using the string class, and actually, beyond not having to worry about the null character and all that stuff, one of the major reasons why you're almost always gonna want to use a string class or a string object is that you never have to worry about running out of room. And so notice the getLine function doesn't take a maximum size like cin.getLine did. So please, when you're writing your first programs here using the string class, a lot of things are very similar to C strings. Be careful, make sure you don't use cin.getLine. It doesn't quite work well. So C strings or string. Now strings are a little complicated the first time we see it, but you'll be able to get used to it fairly quickly, I think. Which one should you use? Like I said, in most cases you'll be better off using strings. You may specifically find yourself in situations where you must use a C string, particularly interacting with older code or code written in older languages. So C does not have strings. C has C strings, and C is almost compatible with C++, but things that have to do with objects are not in the C language. And the C language is actually quite popular. So if you program and interact with an operating system, you're probably going to have to use C strings. And many C++ programs will use the operating system facilities. C development is very popular in embedded devices and mobile devices. It's out there, and it's something that you're going to use. And so you don't want to not understand and try to avoid C strings necessarily. But when you're in a situation where you can, go ahead and use strings. C strings are actually going on behind the scenes within a string class. So the string class really is an abstraction around all the messy stuff that we learned about C strings with our null characters. It doesn't go away, it's just implemented on top of it. All right, so to get you used to this, this is a kind of a bigger lab. This lab will probably take you a bit more time than previous ones. I want you to write a program that it's going to work with the string class itself. And I'm going to have you ask the user for a string, not a C string. And I want you to print out the number of vowels, consonants, and words found in the string. So a couple of things to remember. Remember the isAlpha function can determine whether a character is a letter. Once you know it's a letter, you can also use something like a switch statement to determine if a letter is a vowel. Realize that you can access every single character by using the at function and maybe like a for loop. Words are separated by possibly more than one space, and that's a little wrinkle that you're going to want to consider later on. I'd probably start out writing my code such that it assumes there's only one space between words, but eventually you should change your code such that it'll work with a sentence like this that has multiple spaces between some of the words, potentially even maybe some spaces before the first word. You should be able to capture all of those different use cases. Now, like the last lab, I'm going to give you a general recommendation. You don't have to do it this way, but I can tell you that it's probably going to be a lot. You're going to be a much more effective program if you start really getting used to thinking about breaking down problems into separate functions. And so part of the, we're learning a lot of new topics here, but really I think one of the main things that keeps going on in all of these labs is function development. Don't try to do vowels, consonants, words all at once. Break them out independently. Write a function called isVal that takes a single character, not a whole word, but a single character, and returns true or false if it's a vowel. Write a function then, once you get that to work, called count vowels that takes a string and actually loops through everything and calls isVal over and over again. So notice that top-down approach, or sort of a bottom-up approach, right? Maybe you want to start with isVal, test it. Make sure it works for any character, make sure it returns true or false correctly. And then you can use that function over and over again inside count vowels. You can also do that in count consonants. Do the same thing as count vowel, but remember that to check that the letters are not vowels. Remember that not every character value that's not a vowel is a consonant, right? Periods are not vowels, but they're not consonants either. So make sure you keep that you keep account of that. You can write in a separate function called count words, and again, I've given you some extra help with that one as well. So my recommendation is to write all of those functions in order and test them each way. Work very slowly, focusing on all the individual functions that I've gone over, and then just change your main program to read a string from the user, call count vowels, call count consonants, call count words, and print that result out.